My name is Joe Phillips, and I'm here to take you along as we explore the history of Arizona's pavements. Arizona's roads, highways, bridges, railways, and airports form a critical transportation link to the state's residents, visitors, and businesses, providing access to homes, jobs, shopping, and recreation. More than 7.2 million Arizonans drive over 70 million miles annually throughout the state. Each year, more than $330 billion in goods are shipped to and from Arizona, mostly by truck. Having adequate transportation infrastructure is vital to the economic growth of Arizona. Let's take a brief look into the history of Arizona's roads. Arizona achieved statehood on February 14, 1912. However, transportation routes were created long before that. Native Americans established many trade routes across the terrain of present-day Arizona. The first roads built in Arizona were constructed by U.S. Army soldiers stationed within the Arizona Territory. These roads were rudimentary at best and used mostly by wagon trains headed for the California gold rush. The arrival of railroads in the late 1870s changed that. Rail service in Arizona increased the demand for improved roads as businesses and towns across the territory pushed for better connections to the railroad's depots. Many of the routes that followed are now part of the current interstate system. Statehood in 1912 established the Arizona Highway Department. Although almost all of the state's roads were built of dirt and other local materials, few had been properly graded or drained. With increased travel came the increased menace of dust. The Highway Department's solution to this problem was oiled roads. In 1928, the first segment to be oiled was the Tucson-Nogales Highway. World War II led to a dramatic slowdown in road construction as resources were dedicated to the war effort. The end of the war preceded the Great Highway Construction Boom. A surging population growth from the 1950s through the 1970s led to extensive road, highway, and freeway construction and upgrades to match the capabilities of modern vehicles. Modernization of Arizona roadways continued unabated until the 1979 energy crisis, which ultimately caused a stagnation in road construction created by insufficient gas tax revenues. This lack of funding lasted until the late 1980s. In 1985, Maricopa County voters approved the Maricopa County Regional Transportation Plan that was funded by a sales tax increase. Throughout the 1990s and into late 2000s, the largest effort to expand the capacity of Arizona's highway network was underway. Construction of State Route 51, Loop 101, Loop 202, and Loop 303 freeways was part of this undertaking. Arizona continues to expand its freeway systems throughout the state in anticipation of increasing populations and traffic volumes that the region is facing. Throughout Arizona's history, many pavement advancements have been made. Let's take a look at some of the innovative ways that Arizona has paved the road ahead. Arizona has been instrumental in the development of various road paving techniques. Around 1920, Maricopa County's concrete paving program was one of the most ambitious in the country. Several years later, the Arizona Highway Department began experimenting with oiled roads. A mixture of crushed aggregate and oil was placed on the road base and compacted. By 1933, the Arizona Highway Department had oiled nearly 1,000 miles of roadways, making Arizona the leading state in the West for treating its highways with oil. In the 1960s, the city of Phoenix developed the use of rubberized asphalt to resurface city streets. Rubberized asphalt uses an asphalt binder blended with recycled tires ground into crumbs. In the 1990s, Phoenix resurfaced more than 200 miles of streets with rubberized asphalt using 1.1 million recycled tires.
And looking back, it created a whole industry. It created, I think we were far ahead of the time at that time, because what do you do with used tires? What they were doing is send them to Mexico or here, and sometimes burning them. And environmentally, it was a disaster.
Arizona Department of Transportation, or ADOT, also was an enthusiastic user of rubberized asphalt. Research demonstrated that rubberized pavement reduced tire noise by up to 10 decibels.
It all kind of came together in the early 90s, and we started making widespread use of asphalt rubber. Implemented the Quiet Pavements program in Arizona, and primarily in the Phoenix area, placing asphalt rubber friction course over the concrete pavements. And that was a huge success, especially from the public standpoint. We received just numerous kudos from the public about the nice, quiet, smooth pavements that we had.
Since the development of rubberized asphalt, binders have been modified using polymers, latex, and even recycled plastic bags to enhance the performance of asphalt mixtures.
There's a place for the right kind of plastics. And when you engineer it properly, the right kind of plastics done the right way is very promising. And we've done some of that, and we're pretty excited about the future with plastic roads, when done intelligently.
The use of Kevlar fibers was developed and mixed into concrete and asphalt mixtures to mitigate cracking issues associated with pavements. Sustainability has become an important issue for Arizona. Recycled asphalt pavement, or RAP, is used extensively throughout the state. RAP is the process of pulverizing or milling an existing roadway and reusing a portion of that screened material in the production of new asphalt. Arizona State University worked with the City of Phoenix and industry to develop specifications for 100% use of RAP in slurry seal and microsurfacing pavement treatments, further integrating recycled material back into the roadway and out of the landfills. The City of Phoenix and Arizona State University are currently researching the use of solar reflective pavement surface treatments to combat the effects of urban heat island, which is the result of dark roads absorbing hot summer heat, resulting in increased urban temperatures. A reflective surface treatment is sprayed on with light pigment to reflect the sun rays, reducing surface temperature of the road by 10 to 12 degrees Fahrenheit. Throughout the history of roads in Arizona, there have been pavement research pioneers who paved the way for future advancements. Those research pioneers have come from academia, industry, and government and worked together in the development of better roads for all Arizonans. Let's get to know some of the individuals whose work has contributed to the advancement of pavements for Arizona's roadways.
It's funny how you decide how you get into a particular field. In my case, after 2 years of college, you turn around and you say, what am I going to do? Apply for the city. They were hiring engineering technicians, and I was hired. And I went to transfer to the lab. I thought it was interesting. So I got into it by necessity.
Along the way, I was inspired by my dad, who never got a chance to really get a college education. And he really had a fondness for engineers. He worked around engineers. He thought that was a great career. So he kind of led me into that career path. Went from a research engineer to the head of pavement management. I was a pavement management engineer. Then I became the chief pavement design engineer, and we designed pavements all over the state, including all of the MAG freeway system and the concrete corridor down in Tucson.
After graduation from Purdue, I went to the State University of New York at Buffalo. I worked there as an assistant professor for 5 years. And then I came to ASU in 1984, and I have been there since then. I was the first faculty member in pavement at ASU. I was in charge of establishing a pavement program and also building a pavement lab.
My first job with ADOT was a soils engineer, and part of that was in the materials testing lab. And I really enjoyed the work and was fascinated by all phases of materials testing and evaluation. I was in the materials section 35 years, from soils engineer to senior laboratory engineer, materials testing engineer, to state materials engineer, which that position I was in for 14 years.
My dad had been contacted by this company that he had actually worked with in Nevada. And they wanted him to come to work for them just as a superintendent running a crew. My dad said, "Hey, do you want a job?" And I said, "Sure." And our first job was up in Flagstaff with this company, and we both went to work for Saguaro Petroleum and Asphalt. So that was my first experience with rubber. It was a 4-day job, and we were driving back to Payson after that job, and I told my dad I never want to do this again. The work was way too hard. About a week later, I got my paycheck, and then I figured it was probably worthwhile.
I would never realize that a little girl from Arkansas would be here in Phoenix, Arizona, doing what I'm doing now for the Associated General Contractors. I am the Senior Vice President and have been for the last 18 years of my 22 years here at AGC. Well, what's kept me in Arizona is this guy right here, my husband, Bob, next to me.
My father worked for NASA, and so either by DNA or by just osmosis, I sort of always felt like I would end up in a technology-related field. One of the common threads that's kind of been woven throughout my career has been research.
I would say that the launching pad for me was the Asphalt Institute into this industry. Bob and I met at the Asphalt Institute. He was a regional engineer for a certain area within the Institute. I was what they called back then the seminar coordinator, and never did I ever realize the depth and the magnitude of the Institute. It isn't just with the United States. They have international connections everywhere.
Arizona has a splendid record, you might say, of research, at least when I was with the department. When I first came there in 1969, I didn't know much about what was going on, but I learned quickly, I think. We tried a lot of things. We were a shop that was, we'd listen to the arguments, we'd say, okay, let's build a test section, let's see how it goes. And in a way, that's kind of how asphalt rubber came about with the department, was through a lot of testing, a lot of test sections. Many of them were originally built in the city of Phoenix, and they were extraordinarily successful. And so, our research section began to monitor some small test sections that we did as well. They seemed to be very successful.
I think one of the most important persons that we have to acknowledge is Charlie McDonald. He was an old man, and he was always interested in everything. I mean, he knew about astronomy, he knew about everything. And one of the main things that he had was, he said he had a trailer, and it was because of moving, it would crack and it would leak. So he used he mixed a little bit of tar and some rubber he had, and it was a latex thing. It was flexible. I was assigned to help him out. We would put test sections and try all kinds of rubber and so forth. And I was able to, walking down to Charlie Case Tire Company, they had a waste material there, a crumb rubber. So this is where they got the waste tire rubber introduced into his experiments. We had 140 test sections, so he did a lot of research and fine-tuning the properties of this. The first application was at the airport, Sky Harbor, Taxiway C, I think it was. What happened was that the structure of the pavement, the taxiways were not designed for these big jets that came around the early 60s, the 707s.
I was actively involved in more of the implementation of asphalt rubber into the routine construction practices and design practices of ADOT. So prior to that, I worked with Gene Morris in research, and George Way was actively involved, and many others were. Research at ASU, I'm sure, was going on at the time too. And certainly the industry was a part of that, the Asphalt Rubber Producers Group. was actively involved in many of the contractors.
Over the years, I've been able to do different jobs with crews and supervision. Ended up working in a lab quite a bit, and just kind of got my mind full of this intriguing thing of rubber going into asphalt, and what's this all about, and why does it work, and all that kind of stuff. So the more I learned, the more intrigued I got, and the more I felt like, hey, this is cool. This is where I want to be.
That whole program, which started probably about 1970, was something that happened to me just by chance, and led me to a long career, my association with asphalt rubber, rubberized asphalt.
It's been like a dream. I mean, it's like yesterday, and it's been about 60 years. So it was a good experience for me.
When I joined ASU at 1984, the technology back then was vastly different from what we have right now. Back then, we used to have old devices such as penetration test, absolute and kinematic viscosity test to test asphalt binders. We used to have the Marshall hammer, Marshall stability machine. We used to have the kneading compactor. We used to have stabilometer. We don't use these things anymore. So gradually we had to go through updating this equipment throughout the years. And right now, for instance, we have the latest equipment for testing asphalt binder, aggregate, and asphalt mixtures. We have the latest equipment for super pave. We have several electrohydraulic machines to run various tests on asphalt and mixes. We are capable of testing fatigue, testing resilience modulus, dynamic modulus, flow number, flow test, all of these things that are completely different from what we started with. So I had a chance to go through this evolution of equipment, and I can attest in seeing this kind of change throughout the years.
My section inherited doing all of the concrete designs for all the loops and for the concrete corridor in Tucson, and for I-10 and here in town, and I-17 and I-4, and all over, everywhere. Magically, we went from being pretty much an asphalt shop to concrete. One of the things that we noticed was the original concrete sections that were built in the valley, going back to the 1956-57, actually had lasted way beyond their design life. They're still there. Sections of I-17, people are still riding on sections that were built like 1960.
Super Pave was the finished product that came out of the Strategic Highway Research Program. That happened in the late 1980s, in the early 1990s, and it was done primarily at universities. At the end of that, Federal Highways hired the Asphalt Institute to actually assist them in implementing that product, which became known as Super Pave. I had transferred to the Institute's headquarters in Lexington, and that was kind of the center of gravity of all of that. It turns out that as part of that implementation effort, we were charged with developing some of the early mix designs that were used around the country. The very first design was done for US 93 north of Kingman, right here in Arizona.
The other thing that I like to take credit for is in Kansas City, I think it was 1990 or 91, where we introduced a gap grading by changing the gradation from an open to a close until I got the maximum density of that. That's a gap. That's what I'm going to do, which was about 18% voice. So once I got that, then I started mixing with different types of asphalt. To me, that was a highlight in my career. So then I was able to brag about it.
One of the latest projects that I'm probably most proud of is a job that we did almost 3 years ago, and it was for the city of Phoenix. That, hey, we have this idea. Do you have a street that we could try this on? We want something that's really beat up. Well, he gave us Durango Street in front of McDodd. And that was probably one of the worst roads that Phoenix had at the time. And so we came up with this pavement preservation concept. It was a SAMI, an interlayer chip seal with a brand new hot mix type over the top that we had developed. This was one of the first jobs that we tried it on. And here it is 3 years later, and it looks great. So when you look at that road the way it looked before, And our total thickness is 1.5 inches over that road, and it carries all that heavy truck traffic, and all that deformation underneath is not coming through yet. So when we can develop something like that and make it last, that's pretty rewarding.
When I see one of my students is very successful in wherever he or she works, I get rewarded actually, because I feel that my effort in teaching these students is doing something. So I like this.
The development of ATTI, I believe, was in the early 90s, and a lot of us felt there was a need to have trained technicians in the field conducting the materials testing properly. So the feeling was, let's get a program where we can certify technicians conducting Arizona tests. We have the facility at ADOT in this new building to be able to have a location where the people could come and demonstrate that they actually know how to do the tests. So it was a fun many years, but we finally got it going.
We always have two ways that we look at pavement preservation. It's either worst first, or we better spend a little money keeping the good roads good before they get bad. We like to promote the whole thing. You know, you do need to take care of your bad roads before that bad monsoon wipes them out and they're gone, and now you have to reconstruct them. You got to address those ones. But you also have good pavements that might just need a fog seal or something else that you need to do to make sure that you're maintaining that investment. Pavement pres is the only answer. I mean, there's nothing else that's more cost effective than pavement preservation if it's done right, and we recommend the right procedure, for the right road at the right time, as they say.
You take a pavement that is not maintained, it's getting to the point where you can't repair it unless you take it a lot, and that costs a lot of money. But the way we're doing it now is we're trying to get the pavement to last forever, and it can, as long as you maintain it.
That's why I always like to think that the highway is more than just the nuts and bolts of rock and cement and asphalt. You know, it's an artery for commerce. You go to foreign countries that are advanced and doing well, they have wonderful transportation systems.
I find that infrastructure is the common thread in getting us up and going every day. If we don't have healthy drinking water, if we don't have sanitary systems that are working properly, and if we don't have a way to get from one location to another and move goods and services and people, then it makes us nothing more than a third world country, in my opinion. And I think it's very, very important that we continue to maintain and construct new infrastructure in order to just keep Arizona on the progressive path that it's been for years.
Actually, I'm glad that I have been a member of the pavement community in Arizona, and this was rewarding throughout the years.
Reflecting back on my career with ADOT, I think the biggest lesson I learned, and I think I still would have that same lesson today, is work together.
You need to be exposed to ideas and people outside of your company. And so that leads to things like the Arizona Pavements and Materials Conference. That's an opportunity for people to kind of get ideas, you know, outside of their own company. And it actually, I think, it makes you better at what you're doing. It helps your job.
You know, my dad, he wanted me to go to University of Nevada, Reno and get an engineering degree, and I just never did. So it was kind of interesting to kind of learn it in the reverse, you know, and again brought me to where I am today, and with all this experience and everything, it's become quite valuable.
It's been such a wonderful opportunity to work with so many great people involved in this industry, and it is so diverse that you can literally find a career path for yourself in this industry, and I would encourage you to do so.
By the way, as long as you're using the word way, I'm good with it. You know, freeway, you know, I mean, my name is there. You know, it's freeway, throughway, you know, right way, but occasionally there is the wrong way, and try to avoid that as much as I can. But you'll see my name everywhere. You can't get away from it.
Anyway, I don't feel like working now.
I don't blame you. I don't blame you.
If the thing bleeds, if the pavement,
Somebody else's problem.
that's somebody else's problem. That's your problem.
Yeah, that's right.
Pavement engineers are seeking solutions to our current challenges. More emphasis is being paid to environmental impacts and mitigation efforts to combat climate change.
Industry has embraced and has announced that we're working on a program, a climate initiative program for the asphalt industry called the Road Forward. What the Road Forward is our commitment as an industry to get to net carbon zero by 2050. Abatement has to be the #1 priority before we do anything else. So we have to continue to work on how do we make the asphalt, what's the best available control technologies, how do we get our emissions down as low as possible, making great asphalt. We can't give up the quality. The next part of that is the raw materials. So get your production processes in line, get as low of emissions as possible, that's #1. #2 is make sure we're using materials that are carbon friendly. And that's gonna take some people opening their eyes to, maybe we have to look at our raw material selections differently. I personally think that eventually we need to balance our mixes not just with crack resistant and rut resistance, but with a third leg called carbon footprint. And so it should be a 3-prong approach. Make great products and lower carbon footprint. It is doable, and I believe it.
The future of Arizona's roads is already here. Several companies are testing autonomous vehicles throughout the state as Arizona becomes a hub for self-driving vehicles. One company is currently testing driverless cars in Chandler and downtown Phoenix. With the ongoing driver shortage in the trucking industry, automated vehicle manufacturers are also experimenting with autonomous trucks to deliver goods across the country. Cellular communication plays an important role in this endeavor. Upgrading the 5G network throughout the state and ultimately the nation will provide the infrastructure required to safely guide the vehicles of the future. Pavement engineers are actively designing roads which will provide the necessary components to carry the autonomous initiative forward and are getting ready for modes of transportation we have yet to realize. Throughout Arizona's proud history of pavement roads, countless individuals have dedicated their lives to creating better roads for all of us. Even though the torch has been passed to new generations of pavement engineers, we still remember the contributions of those who came before us. Thanks to those pioneers of pavements, we can drive off into those beautiful Arizona sunsets.